Welcome to AgilePath's webinar, Data Governance in the Age of Big Data. Before we get started, I wanted to let you know that we will be taking questions at the end of the webinar. So as you think of questions, go ahead and use your GoToWebinar panel and to send them in, and we'll try to answer as many as possible at the end of the presentation. Afterwards, all attendees will be receiving a link to the full recording of the webinar along with the accompanying white paper. I'm now going to turn it over to Eric Marks, President and CEO of AgilePath.
Thank you, Doug, and welcome everybody to this latest edition of an AgilePath webinar. Today we're focused on big data, but more importantly, we're exploring the impact of big data on data governance requirements in an enterprise. Before we get into the meat of the content, let's take care of a few housekeeping things. Again, Q&A at the end. We will send copies of the slides and a link to the replay of the webinar out. And again, I am the solo presenter today. Our agenda is basically introductory. I'll start out with a big data overview so that those of you that aren't familiar with it can get at least a background of where this stuff came from and what it involves. We'll talk about the data governance landscape and how data governance has traditionally been performed. And then we'll talk about how big data governance challenges traditional approaches to data governance. We'll offer a view, an approach for helping to at least start the big data governance conversation in your organization. And we'll finish up by providing a preliminary roadmap you can tailor for your organization to start to address big data governance. Q&A will be at the end, as Doug said. So I want to open with this quote. It's from an O'Reilly Radar report, but the summary of this quote is that the age of big data is truly here. The future belongs to the companies who figure out how to collect and use data successfully. Google, Amazon, Facebook, and LinkedIn have all tapped into their data streams and made that the core of their success. They were the vanguard, but newer companies are following in their path. There's not a internet company out there or a major enterprise out there now that is not interested in or starting to leverage big data some way, somehow. As I shift forward to the next slide, big data always surfaces as one of the 4 IT megatrends that are driving venture capital investments, that are driving technology adoption in end-user organizations, and that are driving consumer device purchases out there for the everyday users like you and I when we're in our home life. Social media, mobile, and cloud are big and driving things. Big data is one of those as well, and plays an important role over the next several years. Big data offers a tremendous opportunity to an organization. Big data provides business insights that go beyond the traditional data analytics and operational metrics that organizations have used in the past. Big data focuses on massive data sets using new tools and frameworks that can generate a new set of insights and ahas that you previously weren't getting or may not have been getting with your data analysis framework. Every organization can benefit by expanding analytics beyond their traditional structured analytics, their data warehouses, their business intelligence tools, and starting to explore how to combine big data with these traditional views and see what the benefits are. Big data allows you to exploit and extract value from data sets and from data sources that either has been available but the tools didn't allow analysis of it, or more importantly, to start to explore new sources of data and apply analytics in new ways to drive new insights and new concepts. Combining different data in different formats will help you find new insights, new knowledge for your organization. So advanced analytics and big data, when you put these kind of ideas together, they provide an intriguing paradigm shift from traditional analytics and help pave the way to what we call a knowledge-oriented architecture. A knowledge-oriented architecture is specifically geared toward driving information and insights and knowledge out of data assets, creating data products, and driving business value from informational-based products. Let's shift into a little bit of the overview and definition phase for the webinar. Big data refers to a new breed of data analysis tools that have been optimized to perform analytics on very large data sets. These data sets have been beyond the reach of traditional analytic tools and techniques to make use of. From EMC and eBook, they use the statements below that the term big data describes digital information that's collectively large in volume, and we're talking petabytes, terabytes, and exabytes are not on the too distant horizon. Data is in a variety of formats, primarily structured, semi-structured, and unstructured. We'll come back to that. And has high velocity, meaning that it may require streaming analytics, real-time or near real-time processing to make use of that data. So that's kind of definitionally what big data represents. The concepts around big data were really pioneered by Google and have been subsequently adopted by virtually every other internet company out there. So as Google started to build its business model around search, it needed a massive IT infrastructure, Google File System, Big Table, and they developed their MapReduce computational framework to do analytics within that Google File System. Based on driving their business model to dramatic success, as we've all witnessed, Google then began to publish a series of technical papers. The two that come to mind and that most people point to are Google Big Table and Google MapReduce. They were widely read, widely studied, and now every major internet company is using big data somehow based on those innovations. So today, big data startups and major internet companies and other enterprises are rapidly expanding the use and application of big data tools to a wider and wider variety of business challenges. So this begs the question, what makes it big? I've talked about petabytes, terabytes, exabytes in size. Perhaps the most useful thing is Doug Laney's 3Vs thing. Doug Laney came up with this 3Vs discussion back when he was with Metagroup in 2001, and now he's a Gartner analyst. So let's talk about volume, variety, velocity, and value. Volume really does refer to the type of data and the size of the data that is terabytes, petabytes, and now exabytes. So if you think about this, Twitter is producing 12 terabytes of tweets per day. Tweets, of course, are 140 characters long. Do the math. We're talking about 350 billion smart meter readings every year. We're talking about vehicle telemetry data, sensor data ingest, satellite and geospatial imagery, big data sets. So the volume of these data sets are not able to be handled and mastered by traditional approaches to storing and analyzing data. Let's talk about the velocity of data. This really refers to the frequency of data generation, the frequency of arrival, and the frequency that you have to normalize it and ingest it into a storage repository so that you can analyze it. So, and this, of course, has implications for doing streaming analytics based on how speedy that data is arriving on the pipes. But we're talking about things like engine performance data, telemetry data. We're talking about email data is very fast, 2.9 million emails per second. So there's the message coming across and the metadata about the message, and then there's the content of the message coming in. We're talking about greater than 20 hours of video uploaded to YouTube every minute around the globe. We're talking about the volume of Reddit posts every minute and every hour, and we're talking about Facebook updates in near real time. These are large and very rapid data volumes that come in, and you need tools that can handle that data velocity to find the value in the information. On the variety side of things, we're talking about the type of data and the rate of data type or format change. So things that come into this bucket are web logs and server logs from an enterprise perspective, obviously social media and web analysis, web analytics, medical devices, for example, sensor data from cell phones, location data and all that, audio, video, barcode scanners, RFID tags, those kinds of things are making this broad variety of different data types all coming in. And now you need a new set of tools that can make use of these different data types and find value in the combinations of those different data types. Speaking of value, the last one, what is the business value of data, and the value of that data is going to vary dramatically based on what you do with it. But it obviously has analytics value. There are knowledge insights, golden nuggets of ahas that are going to be valued for an organization. This data will be valuable to enable new products and services to help you target new market opportunities. The challenge really for an organization just embarking on a big data journey is to figure out what's valuable to your particular organization, finding the data sets that can help you find that value, and then putting in place the tools and the frameworks to help you extract that data and perform the appropriate analysis. Now, it's important when we talk about big data that we just don't think about MapReduce. I'm sure everybody on the phone has heard about MapReduce, Hadoop MapReduce. Everybody's got a MapReduce, it seems. But I want to caution you, the big data is much more than MapReduce. MapReduce is a computational framework that works on structured and unstructured and semi-structured data, but it in and of itself is not big data. Big data is a bigger topic. And we're talking about the emerging data architecture and analytics frameworks that fall under this umbrella of big data. Big data today, in my view, also includes the ideas around data science and data scientists and how they perform their roles using these kinds of tools. In my view, big data also includes the NoSQL movement and the drive toward using these new tools on unstructured and semi-structured data, especially if the estimates are accurate that 70 to 80% of enterprise information is of the unstructured and semi-structured variety. That makes a difference. Finally, this whole idea of next-gen analytics and knowledge-oriented architecture, organizations right now are trying to transform into this data-driven, information-based enterprise and trying to create data-centric products and services that will drive revenue and drive their business models. So big data, it's a bigger topic than just MapReduce. Bear that in mind. This picture I put in here because in talking about the what is and is not big data, this divides data into those three buckets of structured, semi-structured, and unstructured. And again, this talks to that 70 to 80% of enterprise information being of the unstructured and semi-structured variety. But it's all data at the end of the day. And so big data, while it seems to be more focused on semi-structured and unstructured, all of the data in an enterprise has to be put under this big data umbrella and used collectively to drive value using these kinds of ideas. This slide shows a few of the more common vendors that you'll find in this space. They're broken out into four buckets. There's data storage technologies in the upper left. That's the things like Hadoop, Cassandra, MongoDB, ParAccel. You can read the rest of them. There's many more coming. There's various data platforms like Hortonworks, Amazon Elastic MapReduce, Amazon Dynamo, MapR, for example, DataStack. So there's a bunch of tools that fall into that category. On the analysis and visualization side, there's things like Mahout, Datamir, Tableau, Apache Storm, many of these types of tools that support analysis and visualization. And of course, on the bottom right are data and development tools like Flume, Scoop, Uzi, and others that you've seen that all are helping to create and develop data streams for or in support of big data requirements. So again, not an exhaustive list, just a representative list of some of the new technologies coming online. And you can bet that there's a ton more coming because this is such a dynamic and rapidly moving space. So it's fair that we should explore what some of the drivers are of big data. If you've been on one of our webinars before, we talked about the next generation IT architecture, and this is the stack that we use to have that discussion. So what's visible and important here are the things circled in red. We have big data at the bottom as part of an enabling set of capabilities for this type of an architecture. And then On the left-hand side, vertical blue bar talks about advanced analytics and BI, and what we're really talking about is the enablement and the consumption of all these data resources in an organization. And this type of a next-gen architecture has to enable big data capabilities with the appropriate tools and IT infrastructure and storage infrastructure, and it has to have the corresponding analytics and the skills, the data scientists, if you will, going forward, that are going to be able to support an enterprise transforming into this knowledge-driven kind of an enterprise. So drivers of big data in this are absolutely related to the things that are in this picture: social, mobile, cloud computing, the big data tools we're talking about. All these things are drivers of, producers of, enablers of the big data requirements of today. This advanced analytics and data architecture in this picture just, again, reinforces the concept that today's enterprises are completely obsessed with data, with analytics, with information. Obviously, some are much better at it than others. Big data is clearly part of this trend, but does not necessarily reflect the scope and challenges that attend this transformation. Analytics and data architectures are undergoing a fundamental shift, a core transformation based on the new sources of data, unstructured and semi-structured data coming in and blending with their traditionally relational RDBMS sorts of data. And so traditional data architectures and analytic models are completely insufficient for today's agile analytics and today's mindset shifting toward big data. So where the heck is all this data coming from? Some of you know that it's clearly being generated by mobile devices. We are walking around every second of every day producing volumes of data that is being harvested in real time by our telecoms, by intelligence agencies, by other people serving ads to us. So mobile devices are an amazing source of, producer of, and consumer of all these sources of data. So photos, videos, tweets, location data, you get it. Web and internet traffic analysis, click streams, online behavioral data, those sorts of things are all being generated today. Those are fodder for big data. Clearly, the social media sites are a gold mine, a treasure trove of volumes, varieties, and velocities of data, from Facebook to YouTube to Twitter, Reddit, LinkedIn, Yahoo, Google, et al., on and on and on. So that's a big source of all this data. Various sensors and devices where we're producing machine-generated data at high speeds, telemetry, engine data, barcodes, RFID, you get it. And then even within an enterprise, web logs, server logs, other things. So, and this is clearly not an exhaustive list, it's just a representative list. And the question becomes one from a data governance perspective of, if we're producing all this data and we're going to start leveraging this data to make use of it, how are we going to govern and manage all of this data, not only from a classical information management perspective, but also from a storage, IT infrastructure, and technological perspective. All very interesting challenges. So this picture is the data governance landscape 3.0, in which we've added big data to the mix. Now this is a bit of a challenging slide. We sometimes call this the DFO, or the data freakout slide, because what we try to do with this is show people all of the moving parts involved in data architecture and data governance. And when people start to absorb all of these components that are part of the data landscape, their heads normally explode. We don't want your heads to explode. But we do want to call attention to how this picture helps kind of present all of the moving parts of data. What I want to focus on, though, right now is that this picture presents some of the classic data dichotomies that are involved in the conversation around data governance. So as you can see here, Top left, top right, we have providers and consumers. Anything in data has to deal with who are the providers of my data, who are my many consumers, and how do I keep them all happy. We're contrasting at the bottom left and right, data in motion, data at rest. And so you need to make sure you understand all of the requirements around data in motion versus data at rest. There's always in this data conversation the divide between the business and the IT organizations and how they're going to allocate responsibility, roles, and ownership for different parts of the data conversation in an organization. And even this vertical dichotomy with data governance at the top and the tools and enablement at the bottom, there's always a tension between look what I can do with these great new data tools and these new analytics, but there's also the need and mandate to govern what you do with data, who has access to the data, how you secure that data. So while these new tools come online and allow some neat whiz-bang analysis, the governance and control over how that data is used, how those analyses are generating business value is in conversation. So, this does, again, reinforce that in data governance, there are these classic tensions in the data governance equation. So they're better summarized on this slide, and there's a few others I'll call out. There's the consumer-provider dichotomy, which we talked about, the IT business ownership dichotomy, which we talked about. There's the tools versus the governance and control dichotomy, which we've covered. We did speak to data in motion and data at rest. There's two more that I'd like to discuss, structured data versus unstructured data, and the whole challenge around how much relational requirement do we have with our data versus how much unstructured and semi-structured requirements do we have for our data in our enterprise. Again, if the stats are correct and 70 to 80% of your data is semi-structured and unstructured, then why have we, to this day, had an over-reliance, it seems, on relational technologies when some of these newer NoSQL and unstructured tools would have been a great investment. So that's going to continue to be an ongoing challenge for organizations because you're going to find that with these new tools coming online, you can use semi-structured and unstructured tools for a lot of your requirements and then use relational things for where they're best optimized. And you might end up finding some very compelling cost savings, but also some performance improvements based on making a stronger architectural determination of what needs to be relationally handled using traditional database storage and traditional analytics, and what can be explored, stored, and analyzed using big data tools, semi-structured and unstructured data analytics. Finally, the real-time batch discussion matters. As we've talked in the velocity of big data, we're in the real-time, near real-time domain with streaming analytics and then trying to generate the information out of data as it's being either generated or ingested. So this high-speed analysis requirement comes to the fore. We've always accepted that we have to live in a batch world for some things, but today's analytics are very much lend themselves into this world of real-time and streaming analytics. So where it makes sense, it's important that you take advantage of it and stop relying on batch processes that result in stale data and obviously poor decisions based on that. Let's shift forward to the data governance landscape now, and let's talk about what is the traditional view of data governance. And as you're probably guessing, it usually involves stewardship and ownership of the data assets. You get into the conversation around data quality, data accuracy. You're trying to find out where the authoritative data sources are for key information. You get into discussions around managing business entities and data models, data definitions, semantics. You end up in somewhere along this line looking at the information management lifecycle requirements end-to-end, exploring retention policies, data classification, those kinds of things. And then you can start to generate a set of policies and controls around access to data, security, et cetera. Again, most often this traditional view of enterprise data governance is allocation of data governance roles and responsibilities between business and IT. Classic view. There's an illustration that follows that kind of represents the classic view of data governance. So I'm showing a set of responsibilities on the left-hand side that are primarily the business's responsibility, including BI strategy, business domain definition, the vocabularies and semantics, determining authoritative systems. Some of those sorts of things are in the business world, if you like to think of it that way. On the far right-hand side are things that are clearly in the IT domain, architecture, information lifecycle support, the canonical data model, XSDs, the XML stuff, data services, integration, ETL tools and ETL programming, the data warehousing, the implementation and technical support for the infrastructure of data warehousing and analytics, database design, the DBAs, the infrastructure, storage, and the IT infrastructure that goes along with this. In the middle, there's a tussle and some tension over the joint ownership of the enterprise logical data model, the business vocabularies, the IT data architecture, and all this feeding up into an enterprise architecture view. So this is just a representation of a way to classically think about data governance and how business and IT share and parts of this, and how business and IT respectively own different parts of the equation. Well, with big data, things start to change. Things start to be a little more difficult. So I come back to our data governance landscape picture and highlight some of the areas in red where the big data conversation starts to change or impact traditional views of data governance. And it's all the things that I've highlighted. It's BI, data science, storage, big data and distributed storage models, ownership and stewardship, information lifecycle management, the whole NoSQL versus relational discussion, data security and access, ETL staging and ingest processes, maybe a few more, maybe all of them, but again, just from a highlighting perspective, big data does impact those areas pretty profoundly. More specifically, it's these kinds of things, if we start to explore the challenges that big data imposes on a data governance process. It's the data stewardship and ownership. It's the data security, privacy. It's all the things we had on the previous thing in red. There's a few new ones on here. For example, how do you define what the appropriate role is for data science and where that role should be? Is it an IT function? Is it a business function? As the data science in the business and the technical side of big data, is that in IT? How do you deal with directed analytics where it's primarily focused on operational reporting and day-to-day stuff versus the non-directed insight discovery that is now possible, not only possible, but it's important to do using data science and some of these big data tools. Who owns the data of big data? More importantly, who owns the results and the insights that you're generating from these tools? So we could go on, but these are some of the highlights around how big data impacts the data governance landscape and brings to the forefront some of these kinds of fundamental questions that have to be addressed under your big data governance approach. So what we've done to help out with this discussion is we've created this picture, this framework to help us at least start to break apart the big data governance requirements from a data governance perspective. So they're in the round wheel in the center, and what we've done is we've carved them into 6 areas of discussion. So first and foremost is the strategy and goals for big data. What are the governance requirements that come out of that discussion? There's the organizational posture and placement of the big data program in an organization. Next is definition of and compliance with appropriate use of big data in an organization. There's a lot of discussion and policy around big data architecture and technology, working our way around the wheel, big data and its impact on the information lifecycle and information lifecycle management processes. That's a biggie. And then we're back to data access, ownership, and security, as you might guess. That's coming to the forefront as well. So let's explore this framework that we've put together in some more detail in the following slides. I should emphasize before we go into the framework that this is new space, so we're creating a big data governance framework where it's essentially, blue sky and white space. So I think what this represents is probably an initial framework to at least get started, and as this industry matures a bit more, we can start to make some better sense out of it. So I should emphasize that. So getting into this big data strategy and goals, it's very important early on with big data that you establish some kind of a business context and strategy and set of goals for this thing. It'd be great if we could augment that with a vision of how business value is generated through the use of big data tools. So if I'm in an insurance organization and I want to make sure I can understand that actuaries can do some really amazing things with the risk models using big data tools. That's an example. There's many other ways in which big data can affect other organizations. But you should be driving to a vision of business value by investing in these kinds of capabilities. That'll be an important governance kind of a landmark for you as you go forward. There should be a business case and a value proposition for big data. Now, obviously, early on, you're probably doing proof of concepts and pilots, but by all means, at some point in time, you've got to formalize a strategy, have a vision for business value, and with that comes a business case and a value proposition for big data. And along with that business case should come some understanding of the investments, the return on them, and the total cost of ownership. That TCO discussion with big data is very important because as you start to accrue more and more data, you grow these massive data sets over time, somebody's going to have to pay for the storage of that data. And the storage costs just will continue to rise. So you need to have some very upfront and ongoing discussions around retention policies, the information management lifecycle, and its impact, the impact of those decisions on storage costs, storage infrastructure, and again, TCO. Also continuing on here, the timeline for strategy execution, metrics, and performance objectives. What I'm really referring to here in this big data strategy and goals kind of a bucket is that you should be looking for execution of this strategy to produce results. And those results should be measurable, should match into some performance objectives, and over time be evaluated on how well they contribute to business success. If you don't have that in place, you're missing an opportunity to deliver value. Lastly, it's important that you understand that big data is a completely new and rapidly evolving space. So you're going to be doing a lot of pilots and proof of concepts in the early days. Proof of concepts and pilots are always risky. They're never meant to be home runs of success. They should be treated as such. But as you get the learnings from proof of concepts and pilots, those should be incorporated into the formalized strategy for big data, and they should become part of the knowledge base of the enterprise so you don't make those mistakes again. So big data strategy and goals become the guideposts against which we'll explore the other big data governance requirements that fall out of this framework. So organizational placement of big data, and this is one that is being wrestled with around the globe today. Where should the big data function be placed in your organization? Should it be a business thing? Should it be an IT thing? Is it a joint program? Is it a shared service? What is big data to your organization? And once you know what it is, you can then make a decision around where the function should be placed, how it should be supported with both business and technology people. And going along with the first question is, what should the data scientists be doing and where should they be placed? are the data scientists in a big data PMO? Are they embedded in the business? Are they embedded in multiple business units? So you've got a whole army of data scientists that are able to use a single big data infrastructure, but pointing it to different sources of data. So again, it's another organizational placement posture kind of a question around the data science function, as well as figuring out where that is relative to the big data program and the infrastructure and tools. How are you going to hire and develop data scientists? Because what people are finding now is it's a highfalutin job title. There aren't a lot of them that really qualify for it out there in the industry. So you're going to have to grow your own. How are you going to do that? What are the requirements for a data scientist? What are their backgrounds? What training do you give them? And what tools and technologies are they going to need to do that job? Next question here under this is defining who's going to define appropriate use of big data. So this isn't the how. This is who within the organizational placement of this function is going to make decisions around what you will and will not do with big data, what you will and will not do with discoveries from using big data, and what products and services you may or may not offer based on using this big data. And then lastly, how will big data be sustained across business and IT? So while this program could be starting out with a lot of support and a lot of fanfare, it'll settle into an ongoing role over time, and so you've got to figure out how to sustain this thing as a core competency going forward, and those are important decisions. So again, some of the early discussions around big data from a big data governance perspective are organizational and function and role in nature. What do you do with it? Where should it be? Who should own it? What should these people do? What should they be focused on? So the appropriate use of big data is now, it's a much bigger conversation. So while I mentioned that on the previous slide, this whole slide is all about the appropriate use. So what is the role of big data analytics in the enterprise? And what's the appropriate use of big data on specific problem sets or opportunities? Deciding those ideas up front is really important before you invest in this tool. This brings back the discussion around are you doing directed or operational analytics and reporting so you know what your business or enterprise is doing day-to-day performance-wise? That's important, no doubt about that. But another aspect of big data is that you can do discovery of new insights, find new ideas, new nuggets of value. And those are not constrained to operational reporting and performance reporting. So, you've got to understand that people that are working on the directed analytics side might get jealous of the people who go be data scientists and do exploratory data discovery on new data sets. So you just have to understand the roles and responsibilities that go with each of those types of activities, and those are certainly not the only two types of activities that will be going on. Who's going to be authorized to leverage big data assets? Not only access the data, but who's going to have access to the tool sets to write new analytics, to leverage the infrastructure, to apply that to big data, because you can use big data for good, you can use big data for nefarious purposes as well. There's also in this big data discussion a new set of consumer and provider dynamics in your organization. And with new sources of data come new consumption patterns and new customers of data. So you need to make sure you understand the new dynamics around customers, providers of data, and how they're going to interact around this big data universe. Next, and certainly I think this is going to be an emerging topic, is as you start to use data to drive and develop new products and services, how do you decide what products and services should be part of your future? So how do you vet and review those things? Do you need a data product management kind of a capability? How do you do this? So again, that's something to be thinking about. And lastly, as you're thinking about appropriate use of big data, you have to think about appropriate sources of data. So are you going to start tapping into multiple external data sources? Those are not going to come free. So how do you make sure you've got budget to get access to new data? But when you bring that data into your organization, it's not traditionally owned by people that own data in your organization today, so you have to make sure you've got an ownership model for new data streaming in that is not going to break in the near term. Let's move forward to the architecture and technology discussion. This is fascinating. As we know, big data architecture and technology is very dynamic, very volatile. So I encourage you to develop a big data reference model and reference architecture that will help you not only make sense of this landscape, but also make sense and monitor new tools and technologies as they come online. So that's really an important point, is to put together some kind of a logical model to help you understand all these different analytics tools, where they fit on a big data continuum, where they fit from a functional and implementation perspective. It's important to encourage proof of concepts and pilots. So we spoke of this a bit earlier. You need to take some risks and get some learnings through proof of concepts and pilots. But the main reason that I emphasize that is because this is such a volatile industry, it's too soon to standardize on tools in each of these categories. So because there's so many changes and versions and new competitors and joining into the fray. So the best thing is to have a couple of contenders in each category of big data requirements you've got, and continue to monitor the landscape and work with them all until the industry starts to mature and shake out. You need, as part of this process, an enterprise architecture approach to vetting the tools and technologies from the reference architecture, reference model framework you need to develop, and then make the appropriate choices as to which tools and technologies not only will be vetted, but will be incorporated into your enterprise. You're going to have to come to grips sooner or later with the NoSQL versus relational decisions, and you're going to have to undo 30 to 40 years of relationalness and start to adopt NoSQL and semi-structured kinds of tools to offset some of that, and that's going to have an impact on your data architecture, your information architecture internally. And this comes to another point. You're going to have to think about big data as a complement to your traditional data warehousing and business intelligence tools. It's not a replacement for, it's a complement to. That said, there's room to again introduce NoSQL and unstructured tools into your organization, and maybe lessen the reliance on relational tools. But the reality is they're going to be working in tandem in some new and exciting ways, with data scientists running over the top. That's probably the way of the future. Lastly, in the technology section, clearly storage architecture and infrastructure is going to be challenged by big data volumes, velocities, varieties. So from an IT operations and infrastructure capability perspective, you need to understand the choices that you make with big data are going to have a cost impact and infrastructure impact on storage, network performance, backup recovery, etc. So that's a lot of technology and architecture stuff in one slide. It's not all of it by any means. I'm just trying to highlight some of the things from a big data governance perspective that probably need to be considered sooner rather than later. Next, the information lifecycle impact. So the information lifecycle, I'm sure everybody on the phone is familiar with it. It basically describes the entire end-to-end value chain, from creating data to managing data, versioning data, ultimately to killing it off and getting rid of it under a appropriate retention policy. So information lifecycle management describes the processes, policies, practices, and tools that align the business value of information with the most appropriate, cost-effective IT infrastructure from this whole end-to-end lifecycle perspective. So big data breaks some of that stuff. Big data has an impact on the end-to-end lifecycle. It drives decisions around retention and data holdings. And the fact that you're doing a big data strategy may put your retention policies in direct conflict with the legal, compliance, and liability people, because the spirit of big data says, I keep holding on to more and more data because I can drive more and more accurate analysis the more data I have. But from a legal or compliance perspective, they want to get rid of the data the very first day they can, so they're reducing liability exposure to the organization. So there's an inherent conflict or tension between the ideals of big data analytics and the fact that you want to accumulate as much data as possible, where from a compliance and legal perspective and liability perspective, it's like, get rid of that data as soon as we can. So you have to get that conflict in policy figured out. Obviously, data classification and retention and those things have an impact on storage costs and storage infrastructure. So can you afford to hold on to the data holdings that you've got so that you can then have future success with future analytics? In other words, this kind of speaks to a retrospective analysis possibility, because again, big data is all about bringing it all in and holding on to it and doing ongoing analysis. So as new data comes in, you can merge that with old data and come up with new insights. But can you really afford to retain the data holdings or not? And that's where that total cost of ownership of the big data equation comes to the forefront. The data volumes and the costs versus the potential future value of data holdings via retrospective analysis is a challenge that you're going to have to come to grips with. And obviously, in this information management lifecycle discussion, the impact of big data on IT operations, backup, archiving, disaster recovery, et cetera, those are all critical things. Again, not all of it, just some of the things that come to the forefront for me as I have these discussions with people. The next category, obvious, there's the data access ownership security thing here. I'm going to totally not cover this in enough detail, so I'm going to pre-apologize, but it's just all three of these are big topics. So you've got to decide who needs to have access to big data assets, to the big data tooling and capability, and who has access to the results. If it sits in the business can make best use of it, but some of the data and some of the support is coming from IT. So how do you deal with this? How does big data affect data security and data access policies? And the fact that you're going to have all this new data persisted in your enterprise, it's going to be awful tempting for some people not to go and get access to that data for their purposes. So you're going to have to secure the data. You're going to have to tie big data in with your identity management and authorization, authentication processes. You're going to have data policies for what, a data classification scheme so that you can mirror that into your identity management process. You get the picture. You're going to have to figure this out soon. How will you deal with and address privacy, security, and compliance risks? Because you're bringing in all this data now. Some of that data may or may not be sensitive, and it may be non-sensitive data you're bringing in, but you generate a sensitive or proprietary golden nugget of knowledge. So you need to make sure that there's a way to classify the results from big data analysis, even though the data that was the raw material for analysis wasn't that sensitive. You get the picture. You're also going to be accessing third-party data sets. More than likely, you're going to be bringing in or renting or buying new sources of data. And so that's a data ownership issue that is got to be addressed. You've got traditional owners of your traditional data assets in your enterprise now, but you're bringing in new sources of data. Who owns them? Is it just the big data program owns them, or do they fall under a particular business unit? And then equally important is who owns the results from big data, the ahas, the analysis, the golden nuggets. Who owns that? Lastly, ownership of data sets, ownership of the big data program, ownership of the discoveries. All this ownership stuff, again, comes to the forefront. So that's a super fast run through the wheel of big data governance and at least a preliminary look at what we think some of the categories are. What I've done is brought back our old friend, the SPOT model. We've used this in multiple of our governance discussions in the past webinars. If you're new to our webinars, they're free. Go visit the website and pull them. You can see our governance framework and all of our governance methodologies back there in those webinars. SPOT model, very quickly, is the preliminary view of designing a governance model. So for any governance model, I need to have the scope of the stakeholders understood. I need a body of policies and controls. I need a set of processes that enforce those policies. I need governance organizations or boards or oversight groups that are going to monitor the situation. And I may or may not have tools and enabling technologies to support the governance requirements of this. So here we're talking about big data governance. Let's take a look at it. Scope, you have to, again, I'm not giving you answers. You have to answer these questions for your organization. Is your big data program a proof of concept? Is it enterprise-wide? Is it within a business unit? Is it a project-level requirement? Are you going to have a big data program or a data science program? So the scope of big data for your organization is going to drive the initial set of governance requirements. More importantly, that will define who your stakeholders are. Stakeholders that own the big data program, who are accountable for it, who benefit from it, stakeholders who have to invest in it or support it, like IT. So depending on what your scope is, that will have a direct impact on who the stakeholders are for big data governance. Once you've got those two things in place, you can then shift over into defining big data policies and decision criteria for strategy, for the organizational ownership, policies around appropriate use, the big data architecture and technology frameworks and choices and policies and decisions and standards, the impact on the information management lifecycle, data access, ownership, and security policies, et cetera. So you need to run through each of those items in the big data governance framework. Think about what are the key policies that we need to figure out right now to govern big data as an extension of our current data governance model. You need a set of big data governance processes. So these governance processes will help you put in the appropriate triggers that will trigger an oversight activity for big data. So, what kind of a review do I need to make more investments in big data? What's the appropriate review process for the architecture decisions around big data? Or how do I get the appropriate oversight for the security, privacy, compliance, and risk dimensions of big data governance? How do I, more importantly than all these, get business alignment and drive business value from a big data thing? There's policy decisions and enforcement processes that help make sure we're getting the right input into those decisions. And then more fundamentally is how am I going to integrate big data into business processes, into IT development, delivery processes? How do I incorporate big data into the core fabric of my enterprise? The governance organizations might look as follows. You might have a stakeholder group that's a big data steering group. You could have an IT executive team or a business and IT joint team as a big data oversight group. You might have a data science oversight capability somewhere. You might decide that big data requires a center of excellence and a working group that has a joint business and IT executive set of sponsors over the top of it. You might have big data fed into your governance risk compliance organization. These are just ideas I threw out there for fun, but there is going to have to be some oversight boards and mechanisms to help you provide oversight into investments, technology, operation, ownership of your big data program in your organization. Tools for big data governance, interesting because all the tools today are tools for performing big data analysis, tools for supporting and enabling big data analysis. There are no tools that I know of today that enable big data governance. It's not to say they're not coming, and it's not to say there might be a couple of things that might help you manage or govern big data. I just don't know of them. But you're going to have to use some kind of technical framework to manage some of the aspects of big data, like the metadata storage, like putting limits on retention policies and the appropriate and the associated storage requirements. So I would say these tools are emerging. I would say if you've got your big data reference model and reference architecture developed, use those to help canvas and monitor the technology landscape for big data governance tools that can help you govern and manage your big data program. So what I'd like to do last, we're coming to the end, is offer a 7-step big data governance roadmap for you. And it looks like this. First of all, I urge you to formalize your big data strategy and your data science strategy. Maybe it's all one thing, but you need to accommodate both. Formalize it. Get it down with a set of goals, objectives, business case, timeline for execution, and get a business sponsor behind it. Number two, determine where the organizational location and placement for big data and data science needs to be. They may be different, that's fine, but just to have the right conversations with the right stakeholders to place these in the organization optimally for business success. Urge you to do that. Number three, think about the guidelines and policies that will help you define appropriate use and business-aligned use of big data resources and capabilities and data. You can use these things inappropriately. Just be proactive around how do you want to use this? And then where it's not clear and you want to do discovery kinds of things, put some boundaries around the discovery processes as well. Number four, get a big data reference model and reference architecture in place. Develop a technology monitoring framework so as new technologies are launched, new startups come online, you can map them into your reference architecture, know what they do, where they fit, and you can monitor what their value is to the organization. As the standards start to emerge around big data, you can use this same framework to manage emerging standards for the big data space. Number five, challenge the relational assumptions of your organization. Explore how you can use NoSQL and unstructured tools as an augmentation to your relational infrastructure, but just as much to replace or offload some of your analysis out of the traditional relational model and into the new world of unstructured. Number six, define your big data governance model. First, by extending any current data governance approaches you have, and then adapt your information management lifecycle accordingly. Last, number seven, begin your big data science program ASAP. Get going with pilots, proof of concepts, get a business sponsor, get going with this stuff. Time is now. If you're not doing it now, you're falling behind. Excuse me. So next steps, we encourage you to reach out to us. We encourage you to reach out to us and have a discussion. We can help provide some vendor-neutral approaches and ideas for strategy, architecture, etc. So by all means, contact us. We can help. We're happy to help, and that's what we're all about. We have time for questions now, so I'm going to turn this over to Doug, and he can facilitate the Q&A.
Thanks, Eric. We did have one question come in, and here it is. What big data actions and strategies are high-performing organizations employing that set them apart from low-performing or lower-performing organizations?
And I'm assuming that's with respect to big data. So
yes, I believe so. Yep.
And so read the questions for me one more time, and then I'll answer it.
Sure, no problem. What big data actions and strategies are high-performing organizations employing that set them apart from lower-performing organizations?
All right. So what our experiences are is, there's two ways that people are going about this, and I've seen high-performing organizations that have started with a heavy emphasis on technology and R&D, doing experimentation massively, driving amazing results. And then after the fact, they're trying to rein in and wrap their big data work with the appropriate governance and architecture controls. It's harder to do it that way. The other high-performing organizations that have been a little bit more cautious are actually doing formal strategy and planning before they do a lot of massive investments in the technology. Those that do it in that sequence are going to be high-performing a little later, but they're not going to have to potentially tear down some previous investments by going out willy-nilly. So that I think sets some high-performing organizations apart from the low-performing organizations. Low-performing organizations aren't even in this discussion, for one. They're very happy with their traditional analytics. They don't think big data has any value for them. They don't think it matters. So that's how I would answer that question. Are there any others?
That was the one question that came in.
Excellent.
I think we're ready to wrap up.
Okay.
So we'd like to
Doug, you want to do the wrap up?
Sure, absolutely. We'd like to take this time to thank you all for dialing in today. If you're interested, again, in learning more about AgilePath's capabilities and solutions, please visit our website at agile-path.com. Thank you again for attending this AgilePath webinar, and we hope everyone has a great day.